Hi, in the previous video in the Kubernetes Simplified series, we learned about theory of what Kubernetes is and its capabilities. In this video, we'll get our hands dirty and do some hands-on deployment of a Spring Boot application to the Kubernetes cluster. Before we begin the demo, there are some concepts that we need to understand. A Kubernetes cluster is made up of masters and the worker nodes. Masters are in charge of the cluster. Basically, they do the scheduling, monitoring, and implement changes. They are also known as control plane. As you see in the figure, it consists of components like controllers, scheduler, API server, and etcd. Ideally, application workloads should not run on masters. Kubernetes cluster also consists of nodes, which are the workers of the cluster. It's also known as minion. It communicates with API server for new work. It executes the work and responds back to the master. In short, whenever you deploy your application, the application gets deployed onto the worker nodes within the cluster. Now, before deploying an application, we need to package it first. So the steps involved for packaging an application for Kubernetes deployments are: number one, develop your application in your preferred language, for example, Java. Containerize the application and build the application into container image and push it to a registry. Declaratively define a pod to hold the containerized app. This means that when we run our apps as a container, it runs within a pod. And the most common way of deploying and managing pods is through a deployment object. So what is a deployment? It's an object that manages a set of identical pods. It can do rolling updates and rollbacks. Behind the scenes, it leverages replica set object for self-healing and scalability. So as you see in the diagram, we have a YAML manifest for the deployment object, and we can use kubectl command to post that to the API server. The API server then creates the deployment object, which internally uses a replica set to manage the set of pods. Each pod would be running the container of our application. The replica sets handle the self-healing and scalability aspect, and the deployment as a whole handles rolling updates and rollbacks. We'll see how this kubectl command creates all these objects in the demo shortly. So I'll be using Docker Desktop for all the demos in this video. I'll include the link for the installation in the description of the video. You can install Docker Desktop on your laptop or desktop based on whether you are on Mac, Linux, or Windows. I'm also using Windows Terminal that comes in the Windows apps. You can download it from the store, App Store. And I'll be executing all the kubectl commands on this Windows Terminal. So as a first step of deploying our application onto the Kubernetes cluster, let's create an image first of our application. So I have a sample Spring Boot application here called microservice 1, which has one REST API exposed at the URL /API/hello1. All it does is returns a hello world string back to the browser. So let's create an image for it. The way we can do that is run a maven command mvn spring boot :build image. So this will create an image, Docker image for our Spring Boot application. It might take some time, so I'll pause the video here. Okay, so the build is success. It created a build image at this location. The name is microservice1 and the label is 001 snapshot. Let's verify it from the Docker desktop terminal. As you see, we have the image created microservice1 with the tag as 001-snapshot. As a next step, we'll create a deployment YAML file. This is a sample deployment YAML. Let's step through the attributes of this YAML file. There are 4 top-level attributes. The first one is the API version. This is the API version that the resource will use. So if you are using a deployment resource, the API version usually would be app/v1. Next is the kind. This indicates the type of the resource. In this case, it's a deployment. Next is the metadata, which has metadata attributes about this deployment resource like name, labels, etc. And the last important one is the spec. It defines attributes like how many replicas or instances of the pod that we want to run. The spec.selector attribute defines how the deployment finds the pods to manage. In this example, it uses match labels, meaning it will manage the pods whose label attribute matches app equals to microservice 1. Next, we have the template attribute, which has metadata and spec. Now, you might wonder why we have two specs here. So, this template attribute defines the pod definition. So, anything under template is for the pod, and what we saw until now was for the deployment object itself. So the template also has metadata like labels, etc. The spec defines the container attributes like name, image, the image pull policy, and the ports to expose the application. Now, as we see in this example, we have provided the image microservice 1 with a tag of 001 snapshot. This is the same image that we created few moments back, microservice 1 with the tag of 001 snapshot. Now let's go ahead and deploy this image into the Kubernetes cluster. So before deploying, let's verify that nothing is running as of now. So kubectl get deployments. It says no resources found. That means nothing is running. Let's check the same with the pods as well. So there are no pods running. So no pods and no deployments running. So let's go ahead and apply that deployment YAML that we just saw. So we'll do kubectl apply -f deployment.yaml. So here you can also provide a directory. In this case, dot means the current directory. If you specify a directory, it will pick all the YAML files within that directory and apply it. But we'll stick to providing the deployment.yaml name here. So as you see, it created the deployment. Now, if we do get deployments, it will show one deployment. And if we do get pods, it will show 3 pods with container creating status. If we use a -w flag, it will keep watching for the changing status. Now we see that all 3 pods change the status to running. Now, how do we check the logs, right? So we can do kubectl logs -f and we can provide the name of the pod. So in this case, it will print out the logs from the container onto the terminal. So you see this Spring banner here because it's a Spring Boot application. So you see Tomcat server started on port 8080 and it says started microservice application in 19 seconds. So this means our application started up successfully. Now let's check it out on the browser if it's working fine. Now, if you recollect in the source code, we had an API at the request mapping /API/hello1. Let's try that on the browser. So it's not working. It says localhost refused to connect. So what's happening? So here in the logs, it says Tomcat started on ports 8080, but on the browser, we see that it's not reachable. So the thing is, this whole thing is running in a container within the Kubernetes cluster. It's not running directly on your local machine. So that's why you're not able to access through the browser. Now, what do we do in order to access the application and check if everything is working fine, right? So for that, we can do port forwarding. We can do kubectl port forward, then the type of resource, which is the deployment, and then the name of the deployment object, which is microservice 1. So I'll copy that. And then you have to provide the port mappings. So 8080 colon 8080. What this means is expose the port 8080 which is running inside the container onto the port 8080 which is running on your local host machine. So let's do that and see what difference it makes. So as you see, it says forwarding from port 8080 to 8080. Now, if we go to the browser and do a refresh, you see it started working. It printed out hello world from one, which is what we had in the code within the Spring Boot application. Now I want to show you something about the replica sets. So let's run a command called kubectl get replica sets. You see there's one replica set running. I mean, we didn't create this explicitly. When we create a deployment, it internally creates a replica set. So what it says is the desired count is 3 because in the YAML file we had specified replicas as 3. So that's why it's saying the desired value is 3 and the current is 3 because there are 3 pods running and all those 3 pods are ready. Now, if there's any deviation in this desired state of 3, replica sets will kick in and try to maintain that desired state count to 3. Let's see a live demo for that. So if we check kubectl get pods dash w, you see there are 3 pods running with a status of running, right? Now let's try to simulate a scenario where one of the pod crashes or goes down, right? Maybe due to out of memory or some other error, right? And let's see then what happens to the number of pods. So just note down the name of the pods that's ending. It ends with G6, GD, and J22. Now in another terminal, I'll simulate the situation where we crash one of the pods. So I'll basically do kubectl delete the name of the pod. What this will do is it will delete the pod and will go again to the first terminal and see what effect it has. Oops, I missed a word pods here. Pod basically, you have to specify what type of resource you are trying to delete. So once we do that, it deleted, and now we see here there were 3 running until this point, these 3, and then the moment we deleted, it started terminating this J22 CX pod, and it started a new pod here with the name that ends with L96V8, which went into pending state, and then container creating. Uh, this J22 is the one which we deleted. It went into terminating state. So this new pod is still coming up. It's in the container creating state, and we'll see it can go to running state at any moment. Okay, so it's already running now. So now if we exit this command and do kubectl get pods, we'll see 3 running. So you saw how when we terminate one of the pods, the replica set kicks in and sees that, okay, the number of pods right now is 2, whereas the desired count here was listed as 3. So it tries to match that number. So for for us to go from 2 to 3, it needs to add one more pod, and that's what it did. So in production state, you don't have to worry if any of your application instance goes down. The replica set or basically the deployment object will ensure that the number of replicas that you have mentioned in the YAML file will always be maintained. Now let's also see another scenario where I change the number of replicas here from 3 to 5 and save the file and try to apply this YAML file again, and let's see what impact it has on the running pods. So again, if I do kubectl get pods dash w, we see 3 microservices running. So from the other tab, let me apply that deployment YAML file again. Kubectl apply dash f deployment.yaml, And note that here now we have replicas equal to 5. Earlier it was 3. So let's see what changes it impacts. So it's configured. So as you see here, it's trying to add 2 more pods, because earlier there were 3 running and now the desired state is 5, which means it needs to add 2 more pods, which it did. Now there are 5 pods in a running state. So if we remove that dash w, now we see that there are 5 pods in the running state. So there's another flag which I would like to show you with kubectl get pods is the dash o wide flag. So when you do that, it adds extra columns in the output. So if you see above, it only had name, ready, status, restarts, and age. When you add dash o wide, it added IP, node, nominated node, and some other columns. So IP indicates the internal IP address of the pod within the Kubernetes cluster. And the node is the node or the worker node on which this pod is running. So since we are on Docker desktop locally, it shows only one node. But in case of your production workloads, there'll be more than one worker nodes on your Kubernetes cluster. So the pods will get evenly distributed on different nodes, so that even if one node goes down, there'll be pods running on other nodes. Another important command to have it handy is the describe command. So kubectl describe pod and then the name of the pod. So basically it will describe the pod and give all its attributes. The most important ones are the events. Here you see it lists out all the events that happened since the container creation. So it says successfully assigned this to the node, which is Docker desktop. Then the container image is already present on the machine, as we saw from the output Docker images. Then it started creating the container, and then the container started. Now, what if you want to check the YAML file for the pod that is already running, right? So if I do kubectl get pods, so I want to see what is the YAML file corresponding to this last pod, right? So the command to do that is kubectl get pod and then the name of the pod, and the flag is dash o YAML. So this will output the contents as a YAML. So this is a huge YAML file. This corresponds to the pod that was running. You see the API version, the kind as pod. If you remember the YAML file which we created, the kind was deployment, but then the deployment object created the pods internally, and this is the YAML for the pod. Ideally, we can create YAML files for pod as well, but the recommended way is to always create a deployment object and let it manage the pods internally. So if you see, there are a lot more attributes than what we have defined within the templates, which is the pod definition. That's internally the Kubernetes adds all the attributes that it needs to maintain the pods. So if you see, it has attributes like what is the image, what is the image ID, the last transition time, the creation time, etc., the state which is running and started at what time. Now let's see how we can delete the deployment itself. So first let's get the name of the deployment, kubectl get deployment, and here you can even specify deploy as the short name. It works the same way as deployment. So here we see there's one deployment name. So if we have to delete that, we'll do kubectl delete deploy and the name of the deployment. So it says deleted. Now if we see kubectl get pods, So you'll see it's terminating one by one all the five pods because we had specified replicas as five. So now looks like it has terminated all of them. So now if we do get pods, there are no more pods. Do note that if we delete the pod instead of deployment, the replica set will ensure that the desired state would be maintained and you will see a new pod come up. So if you want to delete the entire application, you have to delete the deployment object and not the pod. Now, one last thing I want to show you is we created the deployment using a YAML, but you can create the same using command line as well. So the command is kubectl create deployment and then the image, which in our case was microservice 1001 dash snapshot. So let me copy that. There's a space, extra space here. So it's complaining that I have not provided the name of the deployment. So let me do that here. Provide the name as microservice 1. As you see, it created the deployment object. Now if I do kubectl get deploy, it will show me one deployment and then the pods as well. Note that here it created only one pod because we are not using the YAML file which specifies the replica. By default it will create only one pod unless you specify extra attributes within the command. But the recommendation is always to go with the YAML file. Going with the YAML file is known as declarative way, and doing it through the command is called as imperative way. So it's always recommended to use the declarative way of deploying Kubernetes resources. You can also commit this deployment YAMLs and other YAMLs within your source code using Git or any other source code management that you use within your project. One thing I forgot to show is how we can go into the container, inside the container file system, and check any issues or debug anything if something goes wrong, right? So the command to do that is kubectl exec dash it and the name of the pod and dash dash the shell that you want to execute, right? In this case, it's sh. So when you do that, you get a prompt. Now we are actually within the container, within this pod which we have specified. If you do ls-l, these are all the file systems within the running container or the pod. And if we do workspace, ls-l workspace, you see Spring Boot related directories. So the jars, the classes, everything is within this. So now we are actually within the pod or the container that is running inside the Kubernetes cluster. So that's all I had in this video about Kubernetes nodes, deployment, and pods. Thanks for watching.